Have you ever wondered if something really caused an effect or if it was just a coincidence? Well, today, we're going on a data detective mission. We're going to build a toolkit with 4 super powerful methods to find the real answers hidden in data. Let's get into it.
So picture this, right? A city passes a brand new law. A few months go by and hey, the crime rate actually drops. The mayor's office is thrilled, they're taking a victory lap, but here's the million-dollar question. Did the law actually work, or was something else going on at the same time that pushed crime down? Answering that is so much harder than it looks, and it gets right to the heart of what we're talking about today.
You see, the whole problem boils down to this one incredible idea called the counterfactual. Just think of it like a ghost timeline. It's a parallel universe where that new law was never passed. We can never, ever actually see this other timeline. The whole game, and what all of these tools are designed to do, is to find really clever ways to estimate what that ghost timeline would look like.
Okay, so here's our game plan. We're going to stock our toolkit with 4 different methods. We'll start with the event study, then difference in differences, move on to regression discontinuity, and finish with the synthetic control. And at the end, we'll talk about how to choose the right tool for the job.
First up, let's grab the most intuitive tool in our kit, the event study. This one's pretty straightforward. It's all about just looking at what happens right before and right after something big occurs.
The event study really shines when you've got a single, major event that hits a whole group of people all at once. You know, think about a new national policy that affects everyone, or maybe a massive storm that hits one specific region.
Now here's the catch. For an event study to actually work, you have to believe one big thing. It's the rule of the game. You have to assume that whatever trend was happening before the event would have just kept on going along the same exact path if that event had never happened. This is our first and simplest way of trying to draw that ghost timeline.
Okay, now check this out, because this graph shows the logic perfectly. We're looking at how many people were searching on Google for bird baths. That vertical line in the middle, that's time 0. That's when the first stay-at-home orders hit. See how the trend before that is pretty stable, kind of just bumping along, and then, bam, a huge spike right after. That sharp break from the old trend is our big clue that the stay-at-home order probably caused a whole lot of people to get really, really into bird baths.
But here's the problem, right? How do we know for sure? I mean, what if there was some viral bird video that just happened to come out at the exact same time? To get more confident, we need to level up our toolkit. What if we could find a comparison group, a group that didn't experience the stay-at-home order? Well, that leads us right to our next tool. And that brings us to method number 2, difference in differences. A lot of people just call it DID. This is where we add the superpower of a control group. DID is your go-to method when you have one group that gets some kind of treatment, like that new law in our city example, and another, similar group that doesn't. This lets us compare them side by side, which helps us zero in on the law's real effect.
And of course, this tool has its own rule of the game. It's called the parallel trends assumption. Basically, it means you have to believe that if the new law had never been passed, the crime trend in your first city would have moved in parallel with the crime trend in your comparison city. They don't have to start at the same place, but their ups and downs should have been moving together. This graph just nails the concept. The top line is our treated group, the one that got the law. The bottom line is our control group. See how before the treatment, their trends are pretty much parallel? Now, after the treatment, we use the control group's new path to project where the treated group would have gone. That dotted line, that's our ghost timeline. And the gap that opens up between that ghost timeline and what actually happened, that right there is the estimated effect.
All right, time for the next tool in the box. Method 3 is called regression discontinuity. Now this one is incredibly clever and powerful, but it only works in some very specific situations where there's a really sharp cutoff.
You use this when there's a hard rule that decides who gets something and who doesn't. For instance, maybe students who score an 80 or higher on a test get into a special program. Or maybe everyone who turns 65 suddenly becomes eligible for Medicare. That test score, or that age, is the sharp cutoff.
The logic here is just, it's beautiful. The rule you have to accept is that the people who are just below that cutoff are basically identical to the people who are just above it. A student who scores a 79.9 is, for all intents and purposes, the same as a student who gets an 80.1. The only real difference is that one of them got into the program and the other one didn't.
And this graph shows it all. The horizontal line is the test score, and that vertical line is the cutoff, our 80-point mark. Now look at the dots on either side. They follow a nice smooth trend, but right at that cutoff, wham,
there is a sudden jump up. That jump, that discontinuity, is the causal effect of the program. It's one of the cleanest ways we have to actually see cause and effect out in the real world.
Okay, let's get to our final and maybe most sophisticated tool, the synthetic control method. This is what you pull out when you're dealing with a really tricky case study, like trying to analyze an entire state or a country.
So imagine you want to figure out the effect of a huge new policy in, say, California. What's a good control group for California? I mean, is it Nevada, Oregon, Arizona? None of them are quite right. The synthetic control method has a brilliant answer. Why pick just one? Let's build the perfect one from scratch.
Here's where the magic happens. An algorithm takes a whole bunch of other states, our potential controls, and creates a recipe, like a weighted average. It might decide synthetic California is 40% Texas, 25% Florida, 20% New York, and 15% Colorado. And it chooses those weights very specifically so that this new synthetic version perfectly mirrored the real California's trends on important things before the policy ever happened.
And this right here is the classic example that made this method famous. The solid line is the real per capita cigarette sales in California. The dotted line is our custom-built synthetic California. Look at that. They match almost perfectly before 1988. Then, in 1988, California passes a big tobacco tax, Proposition 99. And you see it happen. The real California sales start to plummet, while the synthetic version keeps on chugging along. That widening gap between the two is just this powerful visual proof of the policy's impact.
So there we have it. We've just filled our toolkit with 4 amazing methods for hunting down cause and effect. Now let's do a quick recap so you know exactly when to pull out each one. Think of this table as your official cheat sheet. If you've got one big event hitting one group, you'll probably reach for an event study. If you've got clear treated and untreated groups, that's a job for difference in differences. See a sharp cutoff rule somewhere? That's your signal for a regression discontinuity. And for those big one-off case studies like a state or a country, the synthetic control is your best friend. Just always remember, each tool is only as good as its core assumption.
You know, in the end, it all comes back to this one idea. The whole goal is to get as close as we possibly can to that unobservable ghost timeline. We can't actually go back in time, but with these tools, we can create the next best thing, a really smart, data-driven guess of what would have been.
So I'll leave you with this thought. Now that you have this powerful toolkit for thinking about cause and effect, what claims or headlines are you going to see differently? The next time you read that X caused Y, you can actually stop and ask, wait a minute, what's the counterfactual here? Did they have a control group? Was there some kind of cutoff? You're now equipped to be a way more critical and a way more informed consumer of data.